Alright, so next we have an amazing duo, Kaif Ahsan and Kumar Soorya, who will be talking about breaking the supply chain life hacking marathon. Okay? Kaif is a coder by passion and a hacker by profession. He started as a software engineer but soon fell in love with art of breaking software. He now works as a product security engineer at Atlassian, and his favorite ice cream flavor is butterscotch. We have Kumar here. So Kumar is security engineer at AWS, where he works with his team internal customers with security incident response on AWS side of shared responsibility model. And his favorite ice cream flavor is from both Kaif and Kumar are the co-hosts of their YouTube channel Everything Cyber, where they share hands-on and conversational videos on tech and cybersecurity. So, like, info site.
Okay.
All right, let's get them started.
When you write it, you don't really figure out when someone says it out loud, how it's going to listen. And now when she was reading out loud, I was like, can people hear us at the back? I'll do my test. Okay. Good morning, Melbourne. Are you all doing today? Awesome. Welcome to our talk, Breaking the Supply Chain Live Hacking Marathon. In this talk, we want to share a story with you guys, a story of trust. So, it begins with a long time ago, in a galaxy not so far away, when humans invented computers in the early days, they didn't really have lock screens or passwords. Back in the days, this room would be full of computers. You thought you could log into one, or not one, actually log into one, get access to one, and then go about many ways. There was a lot of implicit trust in the user and the device. And as years progress, you can see trust being exploited again and again, and fast forward now, we have password managers who have paid hardware keys and so on. This phenomenon of trust and then on a single party and then it getting exploited after on is not unfortunately so uncommon in the world of computers. In the early days of internet, we have seen the open network security attack. In the 2010 all-round web security attack and so on. It's not a long time ago when we used to have websites and apps where we have input boxes where we expect people to put in text, and they put more stuff apart from text, and our app would take that and even run that while time. So coming back to this relationship of trust. When I was learning about all the security stuff I come from a dev background, all the security stuff later in my career, and I learned about remote code execution. It struck me as how much trust we actually put in when we run a command like git install package name or npm install package name. We have a seemingly random package made by a seemingly random person who may or may not know. It's on a distant corner of the internet. We bring it on and run on our top or running our apps or running the computers. Now, that's not inherently a bad thing. Why we invent the wheel, right? This is one of my favorite comments from XACD, that the breakneck pace of software development is largely due to the fact that we can stand on the shoulders of giants. And even in this conference, there's so many talks which leverage existing technology and builds up on it. It will be a real shame if we do everything ourselves, which is fine. But what we have also seen that attackers have realized that we have taken that implicit trust that can be exploited. So in the recent times, we have seen an exponential rise in supply chain attacks as well. Now, when we say supply chain attacks, often it comes off as something very complex or hard to do. In this talk, we really want to showcase that it's really not. It's something that can be doable very easily, but the impact is really high. And how can we continue using those beloved package we love without putting too much trust? So in this talk, let's break the supply chain. How we're gonna do that is we're gonna have a few live attack demos, and obviously we're all builders here, so we'll have all the contributors we can against that. Now, this talk originally was designed for an hour. Even in other conferences, we have lots of time. As we know, this is 35-ish minutes we have, thanks to the additional 5 minutes we got at the start. But still, I don't think it's enough to cover all the demos we had in place, but we're still gonna cover the majority of the demo. And there will be a last demo plus plus. Think of it more like a DLC package of the main demo that you can explore a little bit. But that's it, we have time. So if you see us clicking through the slides, rushing at the end, that's just it for our time, because we really wanna take in some content from devs. Because I work in software security, Kumar's in more on the security side. We get a lot of questions from devs all the time when we work with them on the features. So we want to be that here. So we want lots of people ask this question. I realize I must have got myself a hole there if people ask it. Cool. I'll pass to you.
This general disclaimer, this won't test research, excited, and there's already set up always. Also, these are indeed based on real incidents that we've seen across the industry, but there may be some modifications, so we can fit into the metric that we have. So, getting started, how did we get some initial access? So to set up the scene, me and Kaif, we used to hackers. We're pretty broke, can't afford the pizza, so we couldn't cash. So, Kaif, it seems like you've been traveling through different repos. It seems like you found something interesting.
Good news, we're not going hungry tonight. I have found. I was going to GitHub and found that this interesting package, deprecation notice, that SC demo OS package has been deprecated. And all versions 1 will now be deprecated, and people are asked to migrate to version 2. I think it's an interesting thing we should explore, because I know that it doesn't take time for people to migrate to a new version. And when we have applications like this, people always leave behind to extend it again, and you pick up on something.
Yeah, that's what check out.
Yeah.
Look at the package. Very simple access. But I really found well. Very useful indeed. Let's go back to this notes. Sorry. Seems pretty interesting, but I'll come to the side. So, to start off, it looks like we're getting some of Europe. We have a target URL in this case, which appears to be a digital open spaces, which being hard-coded in. Oh, sorry.
Please see if we can zoom it in.
Oh, easy.
Thank you.
Okay, cool. So
I would say that it's fine if you can't read the individual text, but if the 1, 2, and 3, you can read the text for that. No?
no.
Okay, so we'll narrate as well
Yes.
as we don't
Cool.
want.
Easy. I'll go with each one for easier. So the first one is just a hard-coded target URL. In this case, it's a digital open spaces bucket, and in the end, there's a file or my library that's taken in. The second part is that it's downloading resources from this particular URL, just having the function get that in. And then lastly, once that file is being downloaded, it's executing it. So it says something that you can do there.
Yeah, I also want to say that this packages downloading binaries of product that installation process is not something we are common. Whenever you package and install, there is a phase of node fetch where a lot of the times packages don't put all the data that needs to be there directly on the code. It is very common for it to go grab a binary, run it as part of the installation, to not out of the loop. So it's not always means of scanning for this to pick up. But if we zoom into this hard-coded binary, what we see here is really interesting. So we have what it seems like if people have used cloud hosting providers, it seems like one of the storage options we have the space, this name. From here, I can see it's a row of spaces. Here is the space's name. Then the region, it's from, and then lastly, the file page. Interesting. Can you do anything? Do you find it?
Yeah, I did. Just going through the doors, reversing the that. Found something interesting. It said that if it's greater than a period of 1 week, and the which socket is pending destructed, the bucket will probably be destructed. So does that mean that we can probably grab this bucket after a week?
Let's try it out.
Yeah, easy. Cool. Just go to digital learning spaces. Let's see, try the spaces bucket. We grab. Cool. Let's see. Let's see what that is. Unless someone took it.
And also we have the
So region, yeah. So the second part of the URL was NYC3. So we also mentioned that it's in the same particular region. So let's see what happens when we create the space bucket. Okay.
later is so fast today.
Alright, cool. Seems it's let's see what the URL is here. So as you can see, it's got the same start, GGD Devfest bucket. And then it's also got the second part, which is the NYC3 digital bit. So it's also having the same region. So we just need a lot, so we just need a binary. So I think that we can put something.
Yeah, I cooked up a malicious binary. That's just gonna do something very malicious. It's when you run it, it looks for all the folder in that space and prints all the package JSON. I would have asked if you could anything. If you were a real attacker or smart attacker, I would run Bitcoin miners, of course. But in this case, we keep it simple. Just gonna look for package JSON file, which is fine. I'm gonna go ahead and upload that in my binary. Make sure it's public. Okay, now actually, we have the whole link. Nice. So how might this be exploited?
Yeah. So thinking of this from a end user standpoint, you're a dev, you're in part B, or you're a team that's deploying code, and you're ingesting this particular action, right? So let's go with package base. You can see that in this case, they're ingesting a version 1, which is what's been dedicated, which is what's been affected. So if they go through regular pipeline builds, there's pushing code, it starts running the pipeline, start executing, what ends up happening? If you have just like a general pipeline flow, just go through the different stages, run it through. It appears that the whole pipeline has passed. Like, if you look at it, like, let's say everything looks good, even though the bucket doesn't exist. But if you go and look at one of the steps, you can see that when it's trying to run the specific binary file that was trying to pull from the original thing, it just gives an error message, but the whole build pipeline is just a fail. So what happens now if we rerun this with our new binary that's been uploaded to the exact same URL? So let's try to do that.
So in the previous run, because this file is deleted, everyone the maintainers are thinking it's deleted, they're moved on their merry way. And in this case, it exited out quietly. And this is again not something uncommon. You see sometimes when there's pieces of software missing, the pipelines can be showing all green, so the developer thinks it's also all green. But now, every time there's a fresh npm install, because we have replaced that original resource URL, now there is something called to and
Yeah, and in this case, you can see now this fetch the binary that was there in that particular URL. And as you can see, once it's executed, it's printed out the dependencies that are there with this.
Yeah. And to showcase the impact a bit more, every time, obviously, it's not just pipelines. Imagine you are a dev and you have joined a new company. What do you do after joining a new company? You set up your machines, right? So you're gonna download all the packages, go npm install all. And maybe in that brief period when that package was not being maintained, anytime a new employee joins and runs it, this package will install. And it's just not just for new people. You guys all the time when you run deploying stuff in pipelines and everywhere, you do a fresh install. It will run in all the cases. So what the impact here is you might be able to get access to developer machines as well as access to pipelines. Sometimes pipelines are going on for a long period of time. And these days, after these kind of issues like Bitbucket, GitHub, everyone has protected, put on a lot of protection in pipelines. So even if someone goes into that pipeline, it's not an unsanctioned environment. It's not everything, so it's usually protected by containerized and other way protected. But when these kind of issues were first happening, you saw that you can pop into the pipeline, you have all your build secrets, environment secrets, and much more that you could have potentially changed. So going back to the attack itself, what we have achieved that whenever a new install happens, or user happens, our malicious binary will be downloaded. It was just as simple as that. With a quick overview of what has happened, we identified a risky behavior in an end-of-life package. We took over the deprecated resources. Many of the systems were still using that older version, and that gained us access to them information. So is this likely, Soorya?
Yeah, this is something that did happen in 2023. A bug pretty much got taken over by a hacker on a deprecated package. In this case, it was Atlas events. And then that actor basically uploaded malware. So any of the actors who were like pretty much like going through this file cycle were pretty much downloading the malware. Or any cases. There are some other similar attacks. I'll just put it in two buckets. One is the account itself gets taken over. So the maintainers try to actually takes it over and they're like, cool, I'll upload whatever I want. The other one, which is a bit more complicated, is an actor trying to pretend like as if they're a legitimate maintainer. They're like, hey, it's me. I've done some dev stuff here. Can I please trust me? And they try to build trust and they become a contributor or maintainer of that package itself. And then later on, they just start uploading malicious code. And then that catches people off guard again.
Now, I'm going to say and apologize for this slide early on because this is a very condensed slide. I've seen conference talks entirely on just the topics of this slide. But how do you protect against this kind of attacks? Let's try to go into it. In the interest of time, I'm not going to go into deep. But the first 3 points is what I want to cover and what we have seen most enterprises establish something like that. First of all, controlling the ingestion sources. That doesn't mean that you want to stop developers from accessing packages or reduce their speed, but there needs to be some protection. For example, you all got into this conference, right? And you had to show your QR code and then get into the building. But what if there was multiple ways to get in? What if there was a door right behind it and Soorya and I can also drop from the roof? There's multiple ways to get into this room. And if we didn't protect all of those things and put a sanitized way of coming in, then it's very hard to do these kind of things. A common way people control the ingestion source is often they host their internal versions of NPMs and various registries. We have quite free tools that can do it as well as paid ones. Other one is once you have controlled the ingestion source, now it's time to practice scanning. Now, once you have established that in the conference room, you can only come in from the front door. Now it's time to scan and make sure everyone is authentic. In our case, they will put a QR code to ensure that this person actually is valid, and then you get it. So once you have a route like this, you want to be scanning the packages. The last part of these, create an inventory, which is the industry term you here is as well. This is super handy when you have an incident. What we have seen, people are aware of this incident called Log4j. Can I say raise of hands? Log4j, quite a few, right? And if you guys remember why Log4j was so hectic and ruined people's Christmas, because we simply didn't know where we are using Log4j, because it's not your direct dependencies, it can be transitive dependencies, meaning your dependencies can have dependencies on that, and it's pulling in from there, and you don't even know. And that's a very common case for this kind of supply chain attacks. Why it's so obscure? So creating a list of things like this. So in the let's touch one, let's say an emergency happened, event happens here, and everyone runs out. the organizers can go check that, hey, is all the participants out? Can we do a roll call to make sure that everyone is safe? Similar stuff needs to be done for the software. There's a few other things, but I highly recommend you take a photo and go this slide and go through it in depth. But in interest of time, I'm gonna move forward to the next things. Cool. So the incident timeline so far, we have found a vulnerable package. We have gotten access to CI/CD and internal package names. Also, dinner sorted. But can we also file a copy on the cool. The context is we found internal only package names. What can we do from there? Again, raise of hands. Is people familiar with dependency confusion attacks? One. Cool. All right, you guys are in for a treat. And that one guy, I'm sorry, you're gonna have PTSD. Apologies. So, I'm gonna jump into the, sorry for the monologue. I'm gonna loop in my fellow hacker very soon. But I'm gonna jump into my VS Code to showcase the infrastructure we've got. So basically, imagine one of the packages we had installed. I'm gonna zoom in a bit so people can see. Is something called SC dev internal package. And this internal package is very simple. When you call this package, you just console log, say, I'm the internal package of the company. Very plain and simple, nothing too drastic. Basically, and another thing I want to show is this package is not on the public NPM registry. Where this is living is our own internal registry that I'm just running out of my local host now. But what I'm using is something called Verdaccio. Verdaccio is a Dockerized NPM registry for folks who want to maintain their own NPM registry or internal packages. What you do, you don't want to be putting on public registry, right? You don't want other people to show the code. So they just host their own NPM registry and put there. So we have this package. The package name is GDG Devfest package conveniently. So if I go and search for the GDG Devfest package, it is there. And as you can see, it's version 1.0.24. We've done quite a few test runs and demos of this. For this. But yeah, this is the package we're going to target. And on the other hand, we have another, let's say, dummy repository. So this repository basically calls or depends on this GDG Devfest package. So if we jump on there and say run node script.js, it's just going to say, hey, I'm the internal package of the company. What we have also done here is in the npm rc file, which is your npm config file, I've said that, hey, whenever you're looking for a file, please check the internal registry. This is where we want to get the files from. And if I look my something like npm config list, yeah, we can see that we have also configured the registry to our internal one. Looks all good. So this is the infrastructure setup. Pause, go back to hacker mode for the week. So yeah, what can we do with this?
Is this package available public?
Let's check. Unless something has changed in the last half an hour, things should. So GDG, yes, no, package. It's not.
Cool. I think we can probably look to see if we can put a higher version and look to see if something else would happen.
Yeah, sure. So now we have a malicious package, very malicious. It's just gonna print I'm the public package of the npm registry. So if you remember the last time, our package was saying something like I'm the private package of the internal company, and this one's the public. So here we go in the package JSON file. I'm going to change the name into rename our malicious package as package, and then jump into the folder for that. So what I'm going to do is I'm going to do npm version patch, just bump up a little bit, and then do npm publish -- registry. And instead of the internal one, I'm just gonna upload it online one asking me to do 2FA, hackers gotta be secure. Let me go grab that. Yeah. Cool. Implementation is successful. Now it takes a bit of time for this to show up. So did it publish?
Yep.
It did. So PDG stuff takes a bit of time to compare to its same. So what we are banking here is we have found internal package names. Now you might be wondering how. We have shown one way. What another common way we've seen package names get leaked is when you bundle your JavaScript or other things, and you sometimes have that it can leak from the client-facing software. If you are, yes, it's a modern fast world, but we still have people who have the binary and sell on-prem software. That's not also uncommon. So you can unpack that binary and get nothing from there. Devfest. Aha. So our package is now there. Cool. Now it is up there. Now let's say I go back to this folder. So if I look, I'm in that package. So if I do node script, it's going to say internal package name.json because it's in the current version. Let me remove this package. Again, I will mimic the case where you're a new developer now joining the company, or you're just running it in the pipeline again and it's going to go first install. What happens now if I do npm install the package? npm install name. Cool. So what will happen if I now run node script.js? Run nodes. It says I am the public package of the npm registry. Why? We configured it to be calling from here. Our registry is set to internal. Why is it still getting the public package? Yes, the version numbers are bumped up, but like, is it just basing on version numbers? Shouldn't it listen to our command here? Any guesses from the audience why it still goes and checks, even though we are telling it to bring from the prior registry?
The power key.
Sorry.
There's a power key, the command.
Yes, that's what it is. There's another important piece of the puzzle. Why is it going and checking in the public in the first place when we have configured it to look for the internal?
Did the wildcard version of it?
Wildcard, you're close. What we are doing here is telling it to look for the internal registry, but we are not saying anywhere to not look for the public registry. And that's the main thing here. That this is a very common configuration where we have said it, yep, fetch from here, but there's nothing stopping it from going and pulling. And if, as far as my knowledge goes, it's actually relatively hard just from the npm.rc file to stop it from going outside and bringing it. Cool. So, Soorya, going back. Yeah. So, I think we've configured this. Jumping on. You want to explain again? The gentleman here said the hierarchy. You want to?
Yeah. I think think about it in a simple way. We're requesting to fetch that particular package. What the package manager then does is like it says like, okay, let me go search this in the internal registry, finds that version that we had, checks the version number, and then goes searches in the public registry. And it's like, oh, there's a higher version number of that same package. And this is like the default behavior for most package managers. And then it's like, okay, cool, let me go fetch the public one because that looks to be more updated, and then pulls that in. So now that it gets ingested into your as your dependency within your source code. And that's pretty much it.
Yeah, and this is not something uncommon. Back in 2021, we see large enterprises like Apple, Microsoft, and dozens of others, even us. I had a nightmare trying to fix companies running around, and we still to this day we see dependency confusion, but at that time it was very novel attack, and you could see that it's not something major, it's just a logic issue. And using that simple logic issue, you could have owned multiple companies. And now that it's out in the wild, whenever people see public internal public package names, the first thing they try to do is dependency injection. Other similar attacks that can happen.
Yeah, we also have like habit storing similar names of packages and yeah, registering the deleted packages. Like someone deletes it and you're like, cool, I can take over it.
How do we protect against dependency injection attacks? The first and foremost, most people, what they do, especially if it's on NPM, is utilizing a scope package names. What I mean by that is, let's say if I go back to my NPM, let's say for Atlassian, right? For Atlassian, all the packages registered on NPM start with @Atlassian/package name. So we have gone to NPM and reserved that package name, and all our internal packages start with that scope. So even if the package name leaks, no one can go and register under our name because we're always putting it from that. Now, folks who are more familiar on Django or any kind of Python-based one will know that scoping is not supported in Python. How do we do for that? So that's where version pinning the exact version, it comes in handy, and then strict configuration management. Those are some of the things again, the proactive control side, how are we doing with demo or version pinning and is some of the other things you can do. I do want to touch on the other attacks. So what we have found so far is we found a vulnerable package, we have gotten access to PIC, and now we have done another RC capability at a developer's machine. So now we can assume that we have the RC capability at a dev machine. So this is not going to be we don't have the time to do a full on demos, but we do want to take some things. So I'm going to slightly speed run. Apologies for that. The second demo is pretty much an extension. So if we have gotten access to a dev machine, what can we do? We wanted to showcase this code.
Yeah. So particularly in this case, we'll be looking at how we can manipulate pipelines to extract secrets. So some of the secrets are embedded in or like pulled from environment variables. So how can we press that and get it to depth? So in this particular case, we just have a pipeline. I'll keep speaking. In this particular case, we just have a simple pipeline. It just runs on every pull request, and there's a bunch of steps in terms of like writing the cache with Node and doing some npm install and npm test.
Yeah, so imagine this is we were just running around in the dev machine and we found this repository, and again, and these are that pipeline file. We want to extract company secrets out of this pipeline file. How can we do it? We notice that this pipeline file is configured to run on every pull request. So if we make a small and some additional things on things like branch, we also find these branch restrictions. So basically absolutely no one is allowed to write on that branch, but we can only merge their pull requests, and you also need at least one approval. You need to resolve all tasks and what all the standard stuff, standard best practices we see to protect, which is good. But what if we make a small change to the pipeline file in our local machine? A small line, a line to extract, let's say, interesting information. In this case, a simplified version of it is just print the environment variables. And then we launch a pull request. Sorry, we submit a pull request. What we'll see is in that pull request step, the pipeline will run. It will run with the malicious step, and it will leave the API token. Now, for those who are familiar with Bitbucket, you know that we don't we don't print the unencrypted version in the pipeline when you're trying to print, but we do send the unencrypted version when you want to send it somewhere. So if you have a command that sends or just collects all the pipelines and does a post request or any server we control running, it will then send the unencrypted API token. So the quick attack summary, we identify potential source code to be tampered with. We inject a malicious step and in a build pipeline. And the main issue here is not that this pipeline runs on every pull request, but in an ideal world, what is your production secrets doing in your staging environment? Your staging deployment should not have any production API tokens or anything in it. It should be only using the testing ones. So that was the main issue of insecure build on this.
Yeah.
This is like
Yeah, this did happen in code call. Very similar attack. In this case, the actors just heard it out. So they extracted the environment secrets and then basically sent it to a destination and then used that environment secret to do that stuff.
So that primitive example, it's not actually too far-fetched. Basically, what the attackers did is change the build pipeline file to just this one line, and voila, they suddenly had the access to sequence. Proactive controls, again, securing the build process, something called making sure the build environments are immutable and not can be changed from locally. That's one thing. Building build provenance, as in having guarantee on trust on the build, is something we want to do. And yeah, vulnerability scanning CI/CD and making sure your secrets are segregated in your CI/CD pipeline. That's a big one. So, quick incident timeline so far. We have found a vulnerable package. We got CI/CD access or to internal package names. Awesome. We then used that to do a complete takeover of a dev's machine, and using an insecure building environment in that dev machine, we extracted API tokens and compromised the whole company. So yeah, we're selected. Be there now. Cool. Like we wanted to showcase that these are not very complex attacks. We deliberately chose supply chain attacks can be on entire scale. We deliberately chose the easier kind of attacks, but that has a massive damage. Just to show you guys how easy it is to launch a supply chain attack. And the people who can take a stand against it is the people who are in the room, the devs. So let's all collectively work towards doing the supply chain. Thank you all for listening today. Any questions?
So in the example with the NPM registry having a compromised package on it, when the local registry fetches the compromised package down, does it also update its own internal cache so the whole thing is polluted?
Yes. So the package log.json and all the NPM cache will have now a new package name. It depends on how many times you pull this. We have seen, so it's actually funny that somehow we accidentally one time managed to break our own demo because we have the NPM cache was saving one of the old package names and it was just not downloading. But yeah, you're right on that. So you can essentially pollute the entire environment chain there, not just your local repo.
Anyone else?
Hi, that'll be. Thank you so much, folks, for listening. I think the slides should be in there, but I'll go double check. We just did another conference and I need to go. We updated this one. Cool. Thank you so much, folks, for listening.